Hi students, welcome back to Wisdom Academy YouTube page. In the previous video, you have seen about the eye and the defects of eye. So, you have come to know that eye is a very essential part of the body for the vision of anything, and you also know that what are the various defects which can cause in the eye because of different reasons, by the shortening of eyeball or elongation of eyeball, or maybe because of the change in the focal length of the eyeball, like capacity of your eyeball, ciliary muscles to expand or contract the eyeball. So, all these things causes myopia, hypermetropia, presbyopia, or maybe astigmatism and even cataract we have talked. So, in today's session, I am going to talk about refraction through a prism, refraction of light through a prism. So, first of all, I know most of you will have a wrong perception about what is a prism. Generally, when I say about prism, many of the students, what picture comes in their mind? I think this comes in their mind, if I am right. Right. So, when I say prism, you will have this imagination in your mind, if I am right. Most of you, I am not saying everyone will have, but yeah, most of you will have. And this is a wrong imagination about a prism. This is not a prism. This is a pyramid. What is a prism then? Prism looks something like this. Rather, the prism looks like this. And how we define a prism? Prism is defined as the shape, it is a three-dimensional shape which has same ends. So, suppose I have a triangle here, the other end also should be a triangle, and all the other sides should be flat sides. For example, this I will write it as a triangular based prism. Why? See here, triangle, then I am raising all these faces and again a triangle. So, it is a triangular based prism because triangle is at the top and the bottom, and these faces are flat faces. So, even if I am drawing like this a square and I make like this is a square based prism. It can be a cuboid. So, cuboid is actually a prism. It is a square based prism, or it can be a rectangle based prism. Cube is definitely a square based prism. So, cube, if you see, the base is a square. So, above also it is a square and all the sides are flat. So, this is called any polygon which has similar bases. I can also say parallel bases, and all the other sides are flat, is known as a prism. So, for the experiment and for finding the refraction through a prism, I will use a triangular based prism. So, in this triangular based prism, what happened, now I will just draw the front portion of it. I told this just for you not to have a wrong imagination about a prism, but this is the prism what we are using, and from this side we transfer the light, So, first what I will do, I will take one light, incident ray falling on this. So, this incident ray which was supposed to go like this in this direction will actually get refracted because the medium of light is changing from air to this glass. So, what will happen? For finding where it will diffract, I will draw normal here. This is the normal drawn. So, normal, this angle will be angle of incidence, and you know that whenever a light ray is going from a rarer medium to a denser medium, it bends towards the normal. So, it will bend, this is the normal, it will bend towards normal. So, it will bend like this. Okay. This angle made by the normal and the refracted ray is known as angle of refraction. After it touches the other end of the prism, it will again refract because it is coming from denser medium to a rarer medium. For finding how it will refract, I will draw another normal. Let this be again a normal, and now it was supposed to go straight. It will not go straight, but it will bend away from the normal. So, it was supposed to go like this, but it will go away from the normal like this. Right? This ray is called as incident ray, this ray is called as refracted ray, and this ray will be called as emergent ray. I hope you remember in the last chapter I have talked about all these three types of rays, and the angle made by the emergent ray with the normal is called as angle of emergence. This is angle of incidence, angle of refraction, and angle of emergence. There is another angle which is the angle of prism, which is represented by this. This is called as angle of prism. There is something called as deviation. Deviation is always found by extending the emergent ray and making it to meet with the incident ray. So, if I extend in the backward direction and try to find this, here this angle will be angle of deviation, delta they will write, delta or d also you can write. So, I is the angle of incidence, r is the angle of refraction, E is the angle of emergence, delta is the angle of deviation, and A is the angle of prism. So, in higher classes you will learn about the relationship between all these quantities. What is the relationship between incident ray, emergent ray, angle of deviation and angle of prism? You will learn this thing in the higher standards. So, what difference do you notice between the refraction through this prism, and we studied about refraction through a rectangular glass slab. That is also a prism. I will say it is a rectangular based prism. So, what is the difference you can feel between these two refractions? If you remember, in the case of a glass slab, when the refraction happened, let me draw it again here fastly. Was there any deviation? Please try to recall. Was there any deviation? Let us check that. So, if I extend this incident ray, then you found that incident ray and emergent ray were parallel to each other. So, basically there was no deviation. Yeah, there was some displacement. This is called as lateral displacement d, but there was no deviation. The angle was same. That is why they are parallel. But here you can see there is a deviation too. So, one basic difference between the refraction of glass slab and the refraction of prism is that in glass slab we observe no deviation and there is only a displacement, whereas in the refraction by a prism we experience both displacement and a deviation. Very important thing which will be useful for you in the higher classes. Now, if we want to learn about refraction through a prism, this was done by Newton basically, where he took a prism and he passed white light, the sunlight he passed through it. What he observed, when the white light was passing through a prism, this light was getting dispersed into 7 different colors. So, when it came out, he found that after getting refracted, so it came out in 7 different colors, and he found that all these things, when it came out, there was a band of 7 different colors. So, and what is the order of these colors? It was V, I, B, G, Y, O, R. This is the order in which the light was refracted and coming out. This VIBGYOR is known as violet, indigo, blue, green, yellow, orange and red. I will write here for you. It is violet, indigo, blue, green, yellow, orange and red. So, the white light, which comprises of 7 different colors, was dispersed into its all 7 constituent colors when it was passing through a prism, and that is when Newton learned that white light is comprised of all these 7 different colors of light. If you ask me why it happens because each light has its own wavelength, its own frequency. So, the wavelength of the violet light and wavelength of the red light are extremely different, red being the maximum, violet being the minimum. So, because the wavelengths are different, their deviation is also different. This is about the refraction of light through a prism. So, dispersion of white light into 7 different colors, what can be the most practical application of it? Very simple, it can be rainbow. So, rainbow most of you are seeing when there is a rain and there is sunlight. So, how this rainbow is formed? Rainbow is formed when the light ray from the sunlight, that white light, is going inside the tiny water droplets, and then inside it gets refracted, it gets reflected and finally it gets dispersed. So, suppose this is the air droplet, the light ray will be entering here. Since the medium is changing, it will suffer a refraction here. After suffering a refraction, it will come here, it will suffer a reflection. It suffers a reflection and then it is coming out in this different 7 colors. and you will be able to see from here. So a person who is seeing, he will have an image of 7 different colors. So whenever you want to see rainbow in the rainfall, one condition is sun must be there, because then only the light will get dispersed out. And one thing, sun should be at your back. So suppose sun is in the back and you are standing here and rain is falling there, then you will be able to see the rainbow very clearly. So rainbow is a phenomena where you observe refraction of light, reflection of light and dispersion of light. This question is usually asked in school examinations, that what are the phenomena observed in the formation of rainbow. What are the phenomena observed? It is refraction of light, reflection of light and dispersion of light. Now we come to next topic of today, that is atmospheric refraction. So as the name is saying, the refraction of light happening due to the atmospheric condition. For example, I will tell you that most of you would have observed, when you are going on a sunny day on the road, you may feel that like some few hundred meters ahead of you, some kind of water is present or some kind of wave is forming. Most of you would have felt that. We generally feel that there is some water present little far from us, but when we go near to that place, there is no water. That phenomenon is known as mirage, and that is mostly observed in the hot areas, especially in deserts. But no need of going to the desert for this, even you can see on the roads in a hot summer day. Why that phenomenon occurs? It occurs because of atmospheric refraction. Why it happens? Suppose this is the road and the surface of the road gets heated up by the sunlight always. It becomes very hot. So when the road surface and the water surface becomes very hot, the air above this also becomes very hot. Now hot air is having less density. It starts rising up. So as the density of the air reduces because of being heated up, the hot air starts rising up. So here all the hot airs gets accumulated. Hot air is rising up. Now when the hot air will rise up, the cool air will come. So cool air will be down. So now the properties of hot air and the properties of cool air will not be same. It will be having some differences. So there are two different mediums, hot air and cool air. This will lead to the bending of light. So whenever the light ray is passing through these two mediums, hot air and cool air, the light gets bended, and when it is seen by you, it feels that it is having some waves, and that waves will make you to feel that there is some water present there. But when you go, there will be no water. This phenomenon is observed in deserts by people, and especially the animals like camel get most affected by this, because they will feel, as an animal they may not know this is a mirage, and they may feel that there is some water present in the desert, and when they go near to it, then really there is no water present. Now I am going to talk about another topic of atmospheric refraction, that is twinkling of stars. So most of you have observed this, that stars twinkle. But why do stars twinkle? That is the question of today. We all know stars will twinkle. So when you see at night the stars, they seem to be twinkle. But why do they twinkle? Let us learn about that. So even this phenomena is linked with atmospheric refraction. So you must know that stars are nothing but it is a huge mass which is burning. So it's like even our sun is another star. So the mass of helium gas or hydrogen gas burning at very high temperatures, it is called as a star. So stars are very, very far from us, millions of light years away from us. That millions of light year away source which is heated up and is burning will produce some light from there. That light is acting like a point source present very far. When the light comes in our atmosphere, these light will suffer multiple refractions. Why it suffers multiple refraction? Because it is crossing many layers and coming to you. The layers between you and the star or atmosphere, there are mesosphere, troposphere, stratosphere. All these layers of the atmosphere will have different properties, and so when the light is entering this medium, our atmosphere, it will suffer lot of refractions, and finally when the light reaches our eye, that light suffers too much of bending. And that's the reason what position of star, first of all, what you are seeing is not the exact position, it is the apparent position. So suppose a star is here and you are observing from the earth, then when it enters your eyes, suffering lots and lots of refraction, it will bend, and finally it reaches you. So this bending of light will actually make you to see somewhere here, which was supposed to be here. So its position got changed. This is the original position and this is the apparent position. So while suffering multiple bendings and the light reaches your eye, you may not be able to see the stars at the proper position. But the question is not that. Question is, why does stars twinkle? So I'll tell you why it twinkles. See, the atmospheric layers are not in a constant state. It is having some movement, or it is having some changes. That changes in the medium will change its refractive index, and then the light bending and coming to your eyes, every time it is different. So one point it is in different position, one point is different position. So if you are seeing a light for few seconds, every second the position of star is changing. So it feels like twinkling to you. Sometimes it will not twinkle, it will remain calm. Suddenly it start twinkling, because if it starts twinkling, understand that there is some movement in the layers of the atmosphere, and due to that you are seeing that light stars are getting twinkle. Now I have a question for you here. If stars twinkle, why don't planets twinkle? Because some planets are present nearby and we see them as stars, like Venus, you see, we see it as star. But why do we don't feel the planets twinkling? I want you to comment in the comment section and reply me, why do the planets don't twinkle? I will definitely talk about this topic in my next class. Next topic what I am going to talk today is about sunrise and sunset. So generally, sunrise and sunset are not seen in the real time. Today you will know that sunrise what we are seeing is actually advanced sunrise, and sunset what we are seeing is delayed sunset. What I am meaning by these two things, that before the actual rising of sun, you see the sun. Before the actual sunset of sun, you keep on seeing the sun. The sun has actually set down, but you keep on seeing even after it has set down. So why this happens, and how much time it is there? So in this advanced sunrise and delayed sunset, we get a time of 2 minutes approximately extra. So you can see that when the sun, what sun you are seeing in the sunrise, that sun has risen 2 minutes earlier for you, and what sun you are seeing at sunset, that sunset has actually happened, but till 2 minutes later also you can see the sunset. The reason for that is again atmospheric refraction. So suppose I am on planet Earth, and suppose I am standing somewhere here. I hope you know what is horizon. Horizon is a line which separates the sky from the land or sky from the water. So sky and one medium meets, that end point is called as horizon. Usually we see beaches, we see in some huge deserts, like wherever you can see longest, the point where the sun and the land meets, that line is called as horizon. So suppose I am standing here and I have this horizon for me. Okay. Now what happens when the sun is present below this horizon itself? When the sun is present below the horizon itself, the light ray, which should actually go straight and not touch your eyes, it will suffer refraction in the atmosphere, and it will bend and it will reach your eyes. So actually the light ray should have gone like this if there is no refraction, but the medium of our atmosphere makes it to bend and reach your eyes little earlier. So though the sun is present here, but I will extend it and I will draw it here. This is the real position of sun, and this is the apparent position of sun. Same principle. When the sun even sets up, it will send some light ray, and that light ray will suffer some refraction, and to your eyes it will still be visible. So that is the reason why we have advanced sunrise and delayed sunset. It is obviously because of atmospheric refraction. So in today's class, we learnt about prism's refraction. I told you what is a prism. I told you what are the different colors of light what we achieve if we pass a white light through a prism. And then I talked about different angles like incidence, angle of incidence, angle of refraction, angle of emergence, angle of deviation, and angle of prism. And then I also talked about atmospheric refraction and its various application like mirage. I talked about twinkling of stars. I talked about advanced sunrise and delayed sunset. I also want to tell you one more thing about the prism refraction. That Newton, when he did this Vibgyor experiment and he found that the prism breaks down the light into 7 different colors, he did not stop here. He even tried to make these 7 colors further split, and he did lot of experiments by keeping various prisms here, trying to further disperse the light, but he could not achieve that. Rather, when he kept an inverted prism in front of a prism, it is inverted prism of same angle of prism, what he found, all these lights rays were bending once again, and finally one white light is coming out. So white light, it dispersed into 7 different colors of VIBGYOR, and finally again this VIBGYOR light got combined and coming out of this inverted prism as a white light. So this is one more experiment which was done by Newton to find that white light which gets dispersed in 7 different colors can again be combined together to form white light by keeping an inverted prism in front of the original prism. Usually in the exams they will ask you this question, that how do you convert the white light into once again the white light after dispersion. So you should say that if I keep an inverted prism in front of the original prism, then once again I can recombine these constituent colors and finally white light comes out once again. So with this I am winding up today's session. Please like the video, subscribe the channel and share with your friends. Thank you.